So in the past videos, we talked about geometric sequences, and I apologize I did not get to mention this very important type of sequence, and that is arithmetic sequence. An arithmetic sequence is really similar to geometric sequence, or maybe not so much. Let's see. Well, arithmetic sequences, I want to give you some examples of them before I teach you what they actually are. So, let's see here. 1, 2, and 3. What's the pattern? Okay, let's go on to 1, 10, and 19. Here's a hint. Are they going by a constant rate of change? Okay, the key here is that they're going by a constant rate of change that can be added or subtracted. And here's the difference between arithmetic and geometric. So the opposite here is geometric. What's a good color to represent opposites? That would be blue, dark blue. So there we go. Okay, and so like I said, the difference is that geometric, you're actually multiplying and dividing actually, but here in arithmetic, you're going to be adding and subtracting away. And we can see here that the rate of change, like I said, is not called the ratio, but rather a difference. Think of it this way. A difference can be a negative, like a subtraction. But in this case, you have to memorize that it can be addition as well. And so what I want to talk about is this idea that we can find the nth term of an arithmetic sequence using this formula right here. And I will do that for you here. I will put a star right next to it. And that is your first term plus n minus 1 times your common difference. And your common difference, remember, is the thing that keeps being added onto these numbers. Like in this case, it would be 1. I apologize for the dog work. Okay, and in this case, it would be, your common difference would be positive 9, right? Positive 9. And so on and so forth. And in this case, in this first scenario, I'm asking you what's the common difference of this arithmetic sequence, which is 3, 4, 5, and goes on forever. Well, just as a note, remember here, A1 of course means your first term, and in this case, if I was asking you for the first term, it would be this number here. But I'm going to be only asking you in this question specifically about the difference. And so, what rate of change, or what difference is it going up by in this case? And if you're right, it's 1. I put a really simple example here, and in the next few videos, I'm going to be giving more complex examples where you're going to have to apply a little bit more critical thinking. So, the second instance tells us to apply this formula to find a of 5, or your fifth term, actually. And so, this is very similar to geometric sequences, and all you have to do is plug in this 5 into where n should be. And in this case, I will just plug that in as such. And let's use a different number to signify, or to emphasize that this is going to be our 5, right there, right there. If that's legible at all, of course, and this is going to be our 6. And of course, let's go down with this. So of course, this is going to be 3 plus 24, which essentially is going to be equal to 27. And I hope this was a helpful